Welcome CNG 124 to the midweek kickoff week. So let's see, pages, I believe it's 2 through 5, have to do with what we're working on this week. So as you get to the practice, and maybe you want to do the practice before you start the actual lab assignment, that'll help you just a little bit. So here we're just doing basic class identification. So we're going to look at we're going to be just paying attention to the first octets and only those first octets, because we're just basically doing the first identification of classes. So then once we go into the identify which class it is, 192, I'm going to know it's a class C. So I put that there. And how do I know? For class A, pen. For class A, it goes from 1 to 2, 126. Remember, 127 is not used. Class B goes from 128 to 191. Class B, oops, maybe that's horrible. Let's do it a different way. Let's go pen 1 to 126, 128 to 191, 192 to 223, 224, to 239, 240 to 255. And how do I know this? Remember way back in the beginning, I guess it wasn't way back in the beginning, last week we were talking about drawing out those 8 lines. 1, 2, 3, 4, 5, 6, 7, 8. 128 would be here. 64, 32, 16, 8, 4, 2, 1. Having those correlates directly to the numbers you see on the right-hand side of my sheet. That goes back to the slide saying that the left-hand most binary bits have to be for class A 0 and 1. The highest we can ever go would be, well, I guess we could reach 127, but the highest we'd want to go is just 126. And if we're to take that back, look at the next one, 128, 128. Class B, the leftmost bits would have to be this. For class B, cannot be anything else. For a class C, I don't know why it keeps on doing that. For a class C, you'd have to have 192. Can't include that one. We go all the way up to 223, and then etc. all the way to 224, and then 240. So let me see if I can get rid of all those. And then when I also mentioned that you're going to see the same numbers again and again, let's choose a different color. You're going to see 128, 192, 224, 240 again and again. And with this, it can help you identify, track down where IPs reside in the network. So if we were to go back, look at the next one, we would see that 148 is more than 128, less than 192, so it has to reside in the class B, and write that down. 193, of course, is greater than 192, so we can say that's a class C. So with this little, I wouldn't really call it a trick, it just helps to identify the classes just a tiny bit quicker, And with that, a lot of practice goes a long way in this class, so make sure that you are practicing. Here we have the host bits. With the host bits and the network bits, we're looking at specific areas. The host portion cannot change. When we start to subnet, that is the one area that will always remain static. When we start to, and then when we go dynamic, part of subnetting will be the host portions. So the network is static, cannot change. Host portions can change. To identify these, once again, you just start to look at what kind of class it is. First verify the class, and then verify which parts belong to the network. So if we look at 209, we say that this is a class C, and that part should belong to the network, the last part belonging to a host. 199, C again, greater than 192, smaller than 223, those first three. With the next one, 117, well, it's not really, it's below 126, so it has to be a class A, and it belongs there. That part belongs to the network. Moving to the other side, the class, first one, 198, would be a class C. We'd circle, oops, we're drawing my left hand this time. The 177 only belongs to the host. 223, well, that starts at the end of our class C, but it's still in our class C, so we just circle the end again. 17, class A, the host portion takes up all the way at the end. So once again, as you're getting quicker, I didn't, oops, that's my finger, didn't write any sort of graph down. I guess I could reflect up there, but I just I didn't. I worked with this enough to memorize it, and you should definitely too go through it over and over and over and over and over and over and over. So the more you use it, the better off you'll be, and the easier this class will be. So I'd recommend highly doing these exercises when you do this. Looking at the network addresses. So we have two possibilities, two possible outcomes. As we see with this one at the top, let me change colors. 188.10.18. First we have to verify what class it is. And then we look at the subnet mask, and we can also double verify that the class is matching up. When we look at this one here, it looks like the IP is a class A, but then when we look at the subnet mask, we can see that they're using it as a class C. How is this done? Remember looking back at the slides and doing public and private IP addresses? Well, this would be one of those instances where the network administrator is using a private IP address to get what he wants. So he basically wants a 10 dot address with only 254 addresses. So then he moves it all the way to it's at class A, but it's only being subnetted for 256 addresses. So looking at this next one, it's 192. Oops. Pen. 192. Then we say, okay, default for 192 is 255.255.255.0. Well, a trick here would be to, I guess we could take it longhand and draw out 32 zeros, or actually not 32 zeros, 192 out in binary, 149 out in binary, 24 out in binary, and then 191 out in binary. And then write 24 ones and then 8 zeros and try to figure out the network address. But we can already see that it is a class C. We know that the host portion is the only portion that can change. So we can write out, take a little shortcut and say, since the network portion has to stay the same, the only portion that can change is the host portion. And if we were to multiply 0 times 191, we'd end up with 0. So we can a little bit more quickly find our subnet mask, or not our subnet mask, our network IP through just kind of taking a shortcut instead of writing out 64. That'd be 96 zeros and ones, which I would recommend. Try it once and see if you make it quick, and try it this way to see if you make it quicker. When we go to 150, we recognize it's a Class B. Verify it by looking at 255.255.00. So once again, we look at the network portion, static, does not change, and then host portion does change. So we get the network address of that. With the 10 dot, once again, we verify class A, network portion, host portion. And that's the end of that one. No. On this exercise, we do host addresses, identifying the host portion. Once again, verify that the IP is A, B, or C, and then look at what they're trying to do with it. 222, we can verify that it's a C. 255.255.255.0, definitely verify that as a C, and say this belongs to the host only. With the next one, 128, a Class B, verify that the subnet mask is a Class B subnet mask, and say this belongs to the host. That one rather easy. Shouldn't take you too difficult to complete that one. Default subnet masks is another one. Make sure you're identifying the IP if it's public or private. It might take you a little bit more work on this one, but we can start to guess that everything will have the IP address, or not IP address, subnet mask of its default, and say this one is a Class B. This is what a Class B subnet mask is. For Class C, it'd be 255.255.255.0. So a little bit easier working. I believe that's the last one. Yep, that's the last one. Make sure you practice this week. Next week we look at what is 4 and 5. I forget what. I think we start working at Packet Tracer. That gets us one step closer to actually subnetting. So a deeper comprehension of this week's work will help you out in the future and reduce your time significantly.